Like if you constantly ask somebody like, how would you rate this app, or how's your experience going, right? It's gonna suck, right? So the second part of the talk I wanted to discuss is actually improving UX with ML, right? So how can we use machine learning to improve user experience? Because we talked about how building good apps can improve your ML, but let's talk about the other way. So now we're using machine learning to actually improve our user experience based on data. So who here has heard about A/B testing? Nope, not alpha and beta. Okay, maybe a couple of people. So I'll explain what A/B testing is. So whenever you use an app from a fairly established company, you'll be shown something that's not necessarily the same as your friend, right? So this is kind of when we think about, if you think about alternative truths or people seeing different things on social media, this is exactly what A/B testing is like. In this case, on Netflix, you might be shown different box art for different things, right? Or a bunch of different experiments that the companies do to figure out what you find most engaging or interesting or whatnot. So the ad you might get about some new computer might be completely different than what your friend will get because the company is trying to optimize for your ability to buy it, right? In this case, Netflix is trying to optimize for your viewing time. So they do all these little experiments. So you can do this in a number of ways, right? So you can modify sort of screens. So if you're showing an app, for somebody likes taking transit or taking a scooter rather than taking an Uber, right? You might reorder or select certain categories to show that user in order to improve their experience. Likewise, on the right here, sort of going back to the point of A/B testing, of showing different users different things, everybody might receive a different sort of title screen for a show, right? So for Stranger Things, Netflix talked about how they show 9 different screens to try to get people's attention, right? Some of these are more mysterious, some of them are scarier, right? So depending on your preferences, you'll get a different thing. They're also working on using machine learning to generate these captions automatically or these screens based on parts of the show so that you're actually using machine learning to use machine learning to figure out what people like. So it gets pretty meta pretty quickly. All right, so the other thing here is that oftentimes you get shown different screens or different paths to the same experience, right? So if I want to order food, Uber shows me different ways to do that, right? So there's like a top picks for me, there's like a recommended dishes, and then from like an order again button, right? So to order, for example, Chinese food, right, or a certain type of curry, you might be shown these options from 3 different screens, right? So the app is trying to figure out which path you like to take to do an action, right? So to order something, should you show it on the homepage? Should you show it in a recommended section? Should you give the person a discount? Should you let them choose a store but recommend what kind of food they want, right? So there's a bunch of different ways to order food within this app and many other apps, right? Because the company is trying to figure out how can they get you to order more food and what screens you're going to click on, because everybody clicks on and goes through apps in different ways. So an interesting item, so you probably haven't seen this yet, but for some exams in certain universities or professional exams, there's actually an algorithm that's used to determine if you're going to pass or fail. So you can imagine that if somebody's writing a test with 50 questions and they get the first 30 questions right, it's probably true that they'll get like the next 20 questions right, or a high portion. So if these questions are randomized and fit a certain statistical test, it might make sense just to tell the person, yeah, you passed. You knew this material. There's no point of us sitting here for the next 20 questions of testing your ability, right? So there's actually these computer adaptive tests that are used so that when you write longer exams, whether in university or for professional certificates, if you do well enough at the beginning, you don't have to keep writing it. So it's a pretty cool concept for how we actually can use algorithms and machine learning to predict how well somebody's doing and sort of reduce the amount of time we need. So form and function. So machine learning and UX depends on what you're actually doing, right? So if we're going through a visual interface on a computer, that form is different than typing something out on your phone or your tablet or using a voice assistant. So the machine learning and the UX has to match what you're doing. Otherwise, it becomes fairly clunky, right? Like if you ever see a website, right, that's not optimized for mobile, it's a pretty horrible experience. So this is why we design apps and all these things to be specialized. So in the case of machine learning for UX, so when something is visual, right, you can click exactly on what you want to do, right? It's an explicit signal. When you're talking to an assistant like a Google Home, an Alexa, or Siri or something, right, you need to use a machine learning model to actually translate what the person is saying into an action, whether it's a search or calling somebody, texting somebody, whatever it might be. So in that case, in the voice space, there's a lot of machine learning being used to A, try to figure out what you said, and then B, provide the best result, which is something that doesn't happen as much in sort of visual interfaces, which I think is really interesting because now your main way of communicating with the computer is through a machine learning program. Okay, so thinking about designs. So has everybody used Figma before or seen Figma? No. Okay, so Figma is a tool where you can make designs and basically just draft up web pages or mobile apps or whatnot and lay it out how it is. And the cool thing about Figma is that you can group things into sort of modules or components, right? So you can call something like the main page and it contains everything for that, or even have like a table and group all those components together. Likewise, for different systems, you can do something similar, right? So here we have the Amazon homepage from I think a couple of years ago. And what's interesting is that even though it looks like one page, actually 100 different services that are being used, right? So every piece of information that's being popped up is from a different component and a different data source. So even though it all gets rendered together, there's 100 or maybe even 1,000 at this point, different services bringing up the information, right? Anything from pictures to recommendations to descriptions and all of that, right? So we're not actually going back to one database or data store to get this information. We're getting it back. And the reason that this happens is because it's really hard to scale a company and a team when everybody's working on the same product, right? It's similar to where the expression comes from. There's too many cooks in the kitchen, right? You start stepping on each other's feet and it gets very complicated. So you might have heard of a concept called a microservice, right? Where you build out one small piece of functionality in a program, and then you connect them all together later on. And because each program has a small piece of responsibility, it's much easier to maintain. And you build out these microservices into sort of broader or bigger pieces, right, that bigger teams maintain. And suddenly you have these reusable concepts and components that you can plug in on different parts, right? So when we were talking about the UX part of that, right, if we're swapping the order of components or something else for different users, it becomes really easy because it's not all glued together and tied together. It's easy to interchange and combine, right? So if we design our software in a way that's really modular and sort of service oriented, right, you can do this and enable this powerful concept. And likewise, not sure how many of you have taken a discrete math class in so far. If anybody's taken HL Math and IB, you might have seen some of these formulas or AP class. But basically, if you have a graph, right, and you have more points on it and you connect all of them, it grows in a quadratic fashion. So if you have 3 people working on a certain program, right, there's 3 ways to communicate, like A to B, B to C, C to A, right? You have 6, suddenly there's 15. And if you grow to a bigger organization or company, like even the group we have here, we'll have hundreds of different ways each of us can communicate with each other, right? So when you're writing programs or designing things, this is where this idea of microservices or team modularity is super important, because it just becomes more and more complicated. So this is kind of a neat graph about Amazon and Netflix and their microservices. So what this shows is how different services are actually connected with each other, right? And it kind of looks like some kind of cell or organism or like atom. So here we can see that there's a lot of complexity here about how different services connect, but they're not connecting, not everything is connected to everybody else, right? Because different parts of their software is modular, and they built it out in a way where there are some central services that are really important. For example, the login page or some security features or like a main page, but everything else just needs to talk to what it needs to talk to. So you have all these little components connected together, which lets you build out a much more modular system. So the reason I talk a little bit about this is that when you're building a team for UX software or for machine learning software, typically you want to build out a cross-functional team so that you don't have to have dependencies across the board, right? So we go back to this, and let's say you're a team of only developers, right? And you need a certain skill set from somebody else, right? If you keep adding people onto your team, right, it's going to get bigger and more complicated to work on projects. If you only have teams of like developers or data scientists or machine learning engineers or product managers, right, you lack the skill set from within your small team to do everything you might need to do. So that's where the concept of a cross-functional team comes in mind, where there's knowledge of a certain practice within every team, and every team is autonomous and responsible for what they're doing. So let's say that if Team A is building out a recommendation system for stories in Instagram, right? They have all the skills to do that, right? Designing, building, launching that product. Team B might be focusing on filters, right? And they have all the skills to do that. So now you only need to communicate between Team A and B for sort of higher level decisions rather than smaller things. Okay, I'll talk about Voiceflow in a little bit, but any questions so far? Don't see any right now. Okay, I'll keep going. So I talked about team composition, ML, UX, a bunch of these ideas. And kind of to bring it all together is what is Voiceflow? So Voiceflow is interesting because it's a company that has mostly developers building software for designers, because we build sort of a UX platform. So Voiceflow lets you build conversational assistants with a graphical programming language. So we're a tech company that targets conversational designers in big companies, or just people who want to build Google apps or Alexa skills very quickly. So because of that, we actually need to consider UX a lot, because A, we're selling to people who care a lot about UX, but B, we are a UX tool at the end of the day. So what the product lets you do is you can go ahead and build out an application with the programming language. You can prototype, right, and run some tests on it, and then you can actually deploy it live on your local device or on a web server. And there's some sort of business context on the company. So the company helps over 80,000 teams worldwide. So some of these are really small companies or individuals. Others are much bigger, like some of these companies here. So these are some of our biggest customers, and you've heard of most of them. And the use cases are quite different. So we basically need to build a platform that is useful for banks as well as retail companies, as well as restaurants, and even supporting things like in-car assistance and voice-assisted Barbies, right? So when we think about UX and sort of design, right, when you build a platform, you have to figure out flows and designs that work for a lot of different use cases. So that's kind of some of the interesting problems that we're solving. So in terms of the machine learning stuff within Voiceflow, there's kind of three main aspects to talk about. So one of them is focusing on NLP, which is natural language processing that I mentioned. Is we want to figure out how we can assist people's designs and understand the language they're using better, right? So we're using a number of state-of-the-art techniques. A lot of them are open source, so you can actually go play around with them. The main types of models we're using are called transformers. So there's an open source company called Hugging Face that lets you download a Python module called transformers and basically do a bunch of cool stuff on sort of language data. Anything from sentiment analysis to sort of phrase generation to a bunch of different tasks. So definitely check that out, but we're using those open source modules and sort of applying our own data and techniques on top of that. The other interesting thing is that we're working on real-time systems, right? So within Voiceflow, it's a design tool. And if you're thinking about and you're coding in an IDE, let's say PyCharm or Eclipse or something, and if you're trying to do something and it takes a bunch of time to render something, right, you get annoyed. Likewise, in our tooling, we want to make sure things are fast and responsive. So all our machine learning recommendations need to be fairly instant. And then the last part is that we're trying to improve the UX of our tool, right? So how do we help people build experiences faster and design conversations faster? So we end up, this is why sort of this topic or this intersection of topics is interesting, because I see it sort of day to day, but most people typically don't think about how the two things interact. I also wrote a blog post about our machine learning platform, so you can check that out if you want some more details on what we're working on. I think it's fairly straightforward with anybody who's done some programming before, but you can definitely read more about the concepts mentioned. So here, we were doing a beta with one of our machine learning models. I'll just mute this for now. So we launched a beta with recommendations for phrases that users can put for their chatbots. And we wanted to double check with their users that the models we built made sense. So before putting it into the main tool, we have this thing called Voiceflow Insiders with select users for beta testing, where we can show them certain features ahead of time. So basically, we allowed users to select their projects and then generate phrases for their chatbots. For example, here, it's an ordering pizza step. So we can generate some of those phrases to order pizza, and then the user can give us a thumbs up or thumbs down if it's useful, right? So if we go back to the concepts, right, these are explicit signals if they give it a thumbs up. If they don't, that's kind of an implicit signal, right? Somebody might not get to that or might not like it, right? So we were using our user feedback to try to improve our data and figure out if they actually like it or not. So soon we're actually going to be releasing an interesting new feature, which I'll show you shortly, which has to do with the recommendations, but also some other parts of the app. So this is kind of what the UI and UX will look like for adding this information. So let's say you're building a conversation here and you're adding phrases of what a chatbot can say. We'll give you recommendations, and then again, you can accept or decline them. And that'll allow you to, it'll allow you to have useful items for your conversation, right, without fully typing them out. And it'll give us better data on sort of what you like and don't like. So let me share this other screen. Be confused because it becomes ambiguous. They seem like they're the same, but they have different outcomes. So we built a machine learning model to help distinguish which parts of your phrasing might be confusing between different actions. And we basically give you like a rating, like is this not confusing at all, or like great is not confusing, good, it shouldn't be confusing, and like a low or okay means there might be some confusion with your chatbot. And then you can take some of those phrases and you can sort of move them around, right? So if you have an action for a user to talk to an agent, right, and that same phrase is under something like banking information, that's not great, right? So you'd be able to drag and drop and move it around. So we are adding more and more machine learning into the space, and sort of based on our knowledge and understanding of UX and ML, we're sort of trying to incorporate and make our customers' experience better. So that's mainly it. I'll just summarize some of the key ideas I wanted to talk through. But yeah, so we talked about a lot today. First thing was about metrics, implicit and explicit signals, right? So whenever you're designing an app and you're trying to do some machine learning for it, you need to have good data. So figuring out what your key metrics are and then collecting that data is super important, right? So in Instagram's case, it might be likes and comments and how much time you look at a picture. For us, it might be how quickly somebody can build a prototype or how quickly they correct some of the actions that they do. And understanding explicit and implicit signals, right? Super important because oftentimes you can't collect explicit signals, but try to design a system where you can. So just like when I had those phrases pop up on the screen, we explicitly had like a thumbs up or a thumbs down to try to get that explicit signal from the user. And at the end of the day, your machine learning and data collection should feel natural from within the app. So it should just be part of your UX. If it feels like it's bloaty or extra or doesn't fit well, you should know to redesign it. And then kind of the last point, I didn't talk about this too explicitly, but machine learning isn't complete magic. You need to collect data, you need to process it. There's a lot of work that goes into it. So if you know people talking about that machine learning is changing the world, that is true, but it's not magic, right? ML has certain limitations. And as you study the subject more, you'll get to know what those are and find ways to fix them. So yeah, thanks for listening, and happy to answer any more questions either about the talk or machine learning as an industry in general.
Okay, I think, does anyone else have any questions for Denys?
There a way you can contact me? Sure. I think the team has my email, so feel free to post that. I'll just type it into the chat as well. So email is probably best.
And also one thing to add, if anyone is interested in building with Voiceflow, Voiceflow is actually a sponsor of the engineering challenge this year. So I'll just paste the link in the chat so you guys can redeem, I believe it's like 6 months of premium. So yeah, you guys can use that for your projects. But yeah, does anyone else have any questions? If not, I think we can call it there. Yeah, thanks so much. I guess Dennis for doing this workshop. I'm sure a lot of people like took away a lot of stuff from it, especially as high school